Now I don't.
All right, so we are going to attack today geometry. That's French for geometry. And we are going to use trigonometric ratios to find area. So our first one here, we clearly see this is a pentagon, which the Pentagon in the United States is the largest building in the world.
What?
The largest building by volume in the world is the Pentagon. All right, the number 2 is the People's Palace in Romania, shockingly enough. Okay, so let's count it up. Some of this is going to be mental, so you don't always have to do this, but I'm just walking you through the process. First off, I know that there are 5 sides. That'll come in handy in a moment. But notice what I'm going to need to do. What I'm going to try to do is ultimately, I need to find out information about this reference triangle right here. So if I could find out side lengths or angle measurements or something, I can then use trig to find everything else. We can solve that right triangle. So, just to have the other perspective, if I try to find this angle right there, which is called a central angle, what I need to do is take my 360 degrees, because it's 360 degrees all the way around, and I'm going to divide that by 5. So, again, you don't have to show all this step. You can just punch it in and find it fairly quick. So 72 degrees. So let me just show you where that 72 degrees is. That 72 degrees is this angle right there. But notice what I'm going to do again. The red reference triangle here is actually this, what looks like an equilateral triangle, but it's not. This triangle right here, it's cut in half. So I have to take that 72 and cut it in half. So that's what the next part here will be. I'm going to draw a reference triangle. In other words, just one of the right triangles there, where this is my radius, this is my apothem, and down here is a part of the side. It's half the side. It's not the whole side, it's just half the side of my pentagon. So I'm going to take this, divide by 2, and 36 degrees is what we get right there. Now we actually know what r is according to the original problem. We know what r is. It's 7. So I can substitute that in over here. R equals 7. Now this is where our trigonometric ratio stuff is going to come into, because if I am standing at 36 degrees, this angle, and I'm looking for A, knowing the hypotenuse, let's see. This is my A coincidentally is also my adjacent, but apothem is what it means here. My adjacent over my hypotenuse. So to find out what A is, I need to say the cosine of 36 degrees is equal to A over 7. Okay, so let's plug this puppy into our calculator. So I'm going to multiply both sides by 7 and get a result. 5.66. Now at this point in time, I'm already going to be creating errors in my problem, because I'm taking an infinite decimal, what seems like it, and I'm already truncating it down. So let's see, what about perimeter? I'm going to call this one X right there. So to find that one, I'm not going to use A, because that's an approximate value. So I'm going to say opposite over hypotenuse. So I'm going to go sine of 36 is X over 7. Sine of 36 degrees is X over 7. Now we punch that into our calculator. So 4.11, is that my perimeter?
No.
My perimeter is how many times this?
10.
It's 10 of those, because I have 2 per side and 5 sides. So I should be in approximate mode here. Approximate 41.1. Now I have A, I have P. So all I have to do is plug these things in to my super secret formula. Area is 1/2 AP. So approximately 5.66 times 41.1.
Wow.
116.5. I think the units are units.
Wait, 116 point.
Units squared.
I got 116.3.
So now let's take a gander at this octagon. We know that an octagon has 8 sides, like a stop sign. And we also know that if we take 360 degrees and divide by 8, then I will get that central angle right here. So that will be a 45-degree angle there. Now, as we stated earlier, what we're going to do is now draw a reference triangle. If we use the original triangle right here, we can see quickly what things we're going to need to mark up. This here would be my apothem. This here I'm going to call x. It's part of my side of each side here. It's 1/2 of each side, so we do need to find x and a using that radius, which is a hypotenuse of the reference triangle. So if I were to sketch this out, then I'm going to label this one x. Here's a for apothem, and we actually know the radius being 8. And this here has to be 22.5 degrees because I take the 45 degrees and cut it in half. So, relative to 22 degrees here, this is my opposite and this is my hypotenuse. This is my adjacent over hypotenuse. So if I want to find A, then what I need to do is do cosine of 22.5 degrees is equal to A over 8. Now to find x, and we'll get to that in just a second, but in order to find out what x is, I'm going to do sine of 22.5 degrees, and that's going to be opposite over hypotenuse. Now, both sides are going to multiply by 8, and I can plug that into my calculator. And the same thing there. So A here is going to be approximately 7.39. I'm going to keep the longer version of this in my calculator. Over here, x is going to be approximately 3.06. Now I need to multiply this by 16. Now why 16? Because there are 2 of these per side, and there are 8 sides, to get approximately 48.98. Now I'm going to keep these and these in my calculator, and just to show work, I'm going to substitute things in. So A is approximately 1/2, 48.98 times the apothem, 7.39. And finally, to get 181.02 square units. Now, go ahead and practice this one. Notice here that we are given the radius again, but it doesn't always have to be radius. Notice up here in problem number 1, we are actually given the apothem there. Now, I'm going to and this problem here has to do with finding the area of a triangle given a side angle side. Now, here's a super secret formula that we can actually use. The derivation of it we won't show in this video here, but the area of a triangle is half the product of the lengths of the 2 sides and the sine of the included angle. So BC times the sine of A. So 1/2 is equal to, A is equal to 1/2 BC and the sine of A. All right, so this one here is A, so that's my 68 degrees. And I'm going to say the sine of that. Here's my B or C. It doesn't really matter which one. And then here is my B or C again. And then bring down the 1/2. And here we go. Just plug all this into our calculator. So A is approximately 11.13 square meters. Now, notice this is not 100% accurate, but notice if this is 6 and this is 4, that's clearly not 90 degrees. But if you did multiply them together to find the area of base times height, 1/2 base times height, notice that's very close to 12. So we know that at least we are close to our area, or our answer is close to what we expect. All right, so now try 3 and 4, and then work on the assignment. Thank you much.